Detecting credential stuffing and brute force attacks.
In this chapter, we will simulate a client making unauthorized requests too frequently. For this simulation, we have RioDB receiving logs from our local Nginx. RioDB will detect the attack in real time and immediately engage a playbook that will update Nginx to block the attacker's address. The playbook application used here is just a simple Python program that updates the Nginx blacklist as an illustration. In the real world, your playbook might be a security orchestration automation and response system, or perhaps a cloud function. Also, keep in mind that in the real world, an attacker may disguise the attack as normal traffic simultaneously on different service endpoints or different servers in multiple regions. In that case, RioDB would be collecting logs from all endpoints into a central place for a full picture analysis. Here's a quick look at the playbook program. In a nutshell, when RioDB invokes this service to block the attacker's IP address, this Python program will add the IP address to the Nginx blacklist file and tell Nginx to reload the file. And before I forget, here is a quick look at my Nginx config file. In the HTTP settings, I've added a line to include the blacklist file. Let's go back to the REST client, and we're going to do two things. First, we will create a window in RioDB and call it unauthorized by address 10s. A window is similar to a database view. This window will help us count log records received in the range of 10 seconds, with the condition that the records counted have the response code equal to 401, which is the code for unauthorized. Basically, at any given moment, the window tells us how many unauthorized responses were counted in the past 10 seconds. The partition by clause is used here because we are not counting unauthorized requests for all users globally. We want RioDB to maintain a count for each individual remote address making requests. Each remote address has its own count. After the window is created, we will be able to write queries against it. The second thing we will do is to create a query. We want to select the remote address field from the stream and from the window above, whenever that window count goes above 10. I'm using the number 10 for two unrelated things here, so I hope that's not confusing. The window is maintaining a count of the past 10 seconds, and whenever the count becomes higher than 10 occurrences during the past 10 seconds, this condition will catch it, and the query will have found a threat. And you could also create multiple windows and have more complex query conditions to fine-tune this. Queries run continuously for each and every log received in the stream. Queries repeat thousands or even 1,000,000 times per second. So we need to tell RioDB what to do when the query finds something, and that's where the output clause comes in. In the output section, we specify what plugin to be used whenever the query finds the threat. We will use the HTTP plugin. In parentheses, as usual, we specify the details pertaining to that plugin. Here, I'm telling RioDB to invoke our playbook program on localhost port 4000, sending a JSON payload. We also specify what plugin should be used to format the data being sent. Again, we're just selecting the remote address and naming the column as IP. By using the JSON formatter plugin, the selected field will be formatted as JSON before sending it to the Playbook Block API. Finally, the sleep clause. When RioDB is processing thousands of events per second, we want to avoid triggering the output mechanism thousands of times repeatedly. The sleep clause acts like a cool-off period. Once the query executes that output strategy, the query will not invoke that same output again for at least 10 seconds. We can send multiple commands to RioDB in one go. So let's hit send and see what happens. On the right, RioDB responds confirming that it created the window unauthorized by address 10s, and then it also created a query. Queries don't have a name, just a numeric ID. I've already started the Hello API and the Playbook program. Both Python programs are already running. So let's make a GET request to the Hello API on localhost. reminding the API listens on port 3000. However, the Nginx proxy listens on default port 80. I have set the credentials which are hard-coded in the Hello API source code. Username is John, password is Cats. Let's hit send and see. Nginx relays the successful response from the API. Now, let's add a character to the password to make it unauthorized. And hit send again. Now, Nginx relays the unauthorized response from the API. At this point, the window in RioDB has seen the 401 response code, and it has incremented the count of unauthorized requests to 1. If nothing else happens, the count will clear back to 0 because the window has a time range of 10 seconds. It's also worth pointing out that RioDB has executed the query too, but the count of 1 unauthorized request won't trigger anything because the query is looking for a count greater than 10. To trigger this, we will hit send a bunch of times quickly, at least 12 times. And there you have it. At the 11th time, RioDB detected more than 10 unauthorized requests within 10 seconds from the same requester IP address. It called the playbook program, which immediately blacklisted my IP address and reloaded Nginx. At the 12th request, we see that Nginx is forbidding any further requests from my IP address. The attacker is effectively blocked. Let's have a quick look at the Nginx file under acl/blacklist.conf. You can see the entry that was added automatically. A timestamp was included in case we want a separate process to clear old entries later on. And that's it. All sample code is available at riodb.co.